So in this lesson, we're going to talk to the sort of counterpart to the law of cosines, the law of sines over here. Yesterday, we saw that the law of cosines works great when we have the side case. We know all three sides, or we're given like a side angle side. The law of sines is just stated as such over here. It just says the sine of angle A over side A is going to be equal to the sine of angle B over this side B is equal to the sine of angle C over the side C. This equality here, since there's an equal on both sides, they're all equal to each other. So we can still write that sine A over A is equal to sine C over C. So it's really just plugging in similar to the other one, but whereas this works great when we had two sides and an angle or all three sides, the law of cosines that is, and this should say the law of sines, obviously. The law of sines obviously is going to work particularly great when I have two angles here, right? So in the first one, we're just going to set it up, draw a picture. We have that angle A is 20, angle C is 25, and side C is that much over here. So I have, here's A, B, C. Again, just sketch any picture. It doesn't have to be perfect. It's just to get everything relatively correct. And side C is 80.4. So we want to start out solving this over here, right? Which like equations to use here really just depends on what do you actually have some information on. Notice that sine of angle A has to go with side A, sine of angle B has to go with side B, sine of angle C has to go with side C. So clearly we're going to want to use this part of it. We're going to want to use, in this case, that the sine of C over side C is going to be equal to something now. The question is, do we make this equal to sine B or to sine A? Well, let's try to think about this here. If I'm dealing with the B's, well, I don't have the angle and I don't have the side. So I don't know any of these things. That's not going to help me out. But if I'm dealing with angle A and side A, at least I know the angle and I can solve for the side. So I'm going to want to use that formula here, sine A over A. And now, just like yesterday, once you've set it up correctly, it's just plugging in. It's very easy. So this will be sine of C is 25 degrees divided by side C is 80.4 is equal to sine of 20 over A. Here we have one fraction equal to another. Whenever you have a fraction equal to another, this is the case where we actually cross multiply. Right? Notice you need that equal sign to use the cross multiplication. Way too often I see students trying to cross multiply when there's not an equal sign, and then it's not correct. So we'll cross multiply, we'll get A times the sine of 25 equals 80.4 times the sine of 20. So we're going to solve for side A by dividing by sine of 25, just get it by itself here. And as we pointed out before, if you don't like sine of 25, like since you have the angle measure, it's just a number now. You can just plug that in and use the numbers. I like to wait until it's all on one side there to plug into my calculator. So I would get that side A is 80.4 times sine of 20 over sine of 25, which means that side A is going to be, let's see, 80.4 sine of 20 divided by sine of 25 is going to be 65. I'll say 65.1 is going to be the measure of that. Okay, so this is going to be 65.1. Right, that still leaves angle B and side B over here. So let's try to think about how we're going to get those. Well, now I know two sides. I know two angles over here. I want to find the other side. Well, I kind of glazed over it. I jumped ahead. Just to sort of point out that, like, obviously the easy route was taking A and C in this case, but remember what we talked about yesterday, the angles in a triangle should add up to 180. So actually, if they give us two angles here, they've really given us the third angle as well. So we can find angle B, which is going to be equal to 180, what the triangle has to sum up to, minus the two angles we know, right? And this is what I was saying, that we really know what the other angle is if they give us two of them, if we're given two of them in a problem. And at this point, I can easily use the law of sines again. But the other thing I could have done, let's say I didn't realize or didn't remember this fact over here. Well, I had two sides, I had two angles over here. I just didn't have the angle on the other side. So I could have used the law of cosines, it just would have been a little nasty of a form for us because we would have gotten a bit of a quadratic to solve. It wouldn't be as simple because I didn't have a side opposite the angle I was looking at over here. So easiest is just remember this fact. When I'm given two angles, find the third one first. Right? That way we don't have to mess with like the longer law of cosines or anything. But now that we have that, we can easily set up another relationship. I can say that sine B over side B is equal to, and I have my choice. I can pick sine C over C or sine A over A. It really doesn't matter. I'm going to go with sine C over C just because those were both given to me in the problem. So there's no chance I could have made a rounding error or anything. It's definitely going to be correct there. So I'm just going to plug in now sine of 135 over B is equal to sine of C was how much? 25 over C, which is 80.4. Do a little cross multiplication. We get that B is equal to 80.4 sine of 135 over sine of 25, or that B is equal to, that's going to be, sorry, I'm just looking up the answer, 134.5. Would have been quicker if I just plugged it in. But anyway, and again, we can always do a little sanity check. The shortest side here is side A. The shortest angle is also side A. The longest side here is side B. The longest angle is also side B. So that works out great. Okay, so notice here we were given angle, angle, side. And we use the law of sines here. The law of sines works great when we're given two angles to start out. But it really only works if we're given, like here, we had angle, angle, side, or if we're given angle, side, angle. Okay, notice it works best when we have two angles. It doesn't work great if we have like a side angle case over here. And neither one really works great, the law of cosines or the law of sines. The law of cosines, we're going to get something that's quadratic at best. I don't know, I haven't taken a look at it, or it might not even be solvable. And in this case, we get like, depending on how the numbers work out, you can get that there is one triangle that exists like that. There are two triangles that exist like that, or there are no triangles that exist like that. It kind of depends on the problem. We need a little more information here. We call that the ambiguous case. We're not going to deal with that over here, but just know that we need to have two angles really for the law of sines. You need to know something about two angles. That means you can use the law of cosines in conjunction with this. Like, let's say you know all three sides. I can use the law of cosines to find one angle. And then like on yesterday's problem, like this one over here, I could have used the law of cosines to solve for one of the angles, and then I could have used the law of sines to solve for another one instead of, instead of the law of cosines again. But we need two angles really for the law of, really it works best when we have the two angles here. So let's set up one more. Let's see, we have angle A is, there's A, B, C. Angle A is 98.4. Angle B is 24.6. And side A is 376 over here. So here we've got angle, angle, side again. I have side A and angle A. I have angle B, but not side B over here. You want to solve for all sides and angles. Well, we're given two angles here. That's kind of our key to use the law of sines first. And obviously we're going to have sine A over A because I know both those things. And if I'm looking at this here, well, I don't know anything about C or side C yet. I mean, what I could do first is find what's angle C and use that just like we did before. But since I'm given angle B, I'm going to start out solving for side B because, you know, I don't have to do a step beforehand. I'll get the same answer if I solve for side C first, side and angle C first, but I don't know those yet, so I can wait. Sine of 24.6 over side B, cross multiply, B equals 376 times the sine of 24.6 divided by sine of 98.4. which means that B is equal to what's the wrong column there? B is equal to 157. And that might not be, I might have made a mistake on the key by plugging in something wrong, but it's been pretty close to 98.157 there. Okay, and then just like before, what we could do is solve for angle C here. It's going to be 180 minus all of that, 98.4 minus 24.6. Get whatever number that is and use law of sines again and keep going. But all these problems are going to follow more or less similarly. So I think I'm going to stop it here for this lesson. And I'll see you for tomorrow's lesson where we'll talk about the area of a triangle a little bit more. And that pretty much wraps up this unit.